Hi everybody, I am Rajeshkumar, Assistant Professor, Department of Computer Application, AJ College of Arts and Science. Today we are going to see the topic about graphics and multimedia. In the graphics and multimedia, it will be covering entire computer graphics related things. Major topics are attributes, output primitives, and output attributes of output primitives. The output primitives having a following points. One is a points and lines. Line drawing algorithm. That line drawing algorithm covering two types of line drawing algorithm. One is DDA line drawing algorithm and another one is a Bresenham's line drawing algorithm. And another next topic is a loading frame buffer. Next one is a line function. It will be covering different type of line functions. It will be available for the computer graphics designing. Then next one is a circle generating algorithm. It will be more useful for generating circles in the graphics. Next one is a ellipse. Ellipse is same like that. It will be covering a little bit difference in the circles. Same thing it will be covering. Next one is a attributes of output primitives. First one is a line attribute. It will be data collected for the line output line attributes. Next one is a curve attribute. Next one is a color and grayscale level. It will be for the color and grayscale level changes in the line and curve attributes. Next one is a area filling. It will be useful for filling the areas of specific areas. It will be covered through the points. Next one is a character attribute. We are using a multiple characters in the graphics. That characters attributes will be displayed and changed through these character attributes. The first topic is basic of graphics. What is meant by graphics? The graphic is a simply image displayed on a computer screen. Graphic is often contrasted with the text which comprised of characters such as a number and letter rather than the image. That will be more useful for presenting the information. Next one is the basic element constitute a graph is called output primitives. Each output primitive has an associated set of attributes such as line, width and line color for the lines. Various graphic systems have a different graphic primitives. Applications of computer graphics. We are using a computer graphics in more places. For example, we are having a basic application. It will be working on the real world. First one is a CAD design. It will be more useful for designing the tools. There is a CAD, computer aided design. Next one is a computer aided geometric design. Same like that, but it will be having some advanced entertainment. That is an animation, games like that, etc. Then computer art. It will be for designing art diagrams. Presentation graphics, educational and training, geographic informations. It will be for the Google Maps like that. Visualization, scientific visualization, informative visualization. It will be visualizing the things. Next one is a medical visualization. Next one is a image processing. Next one is a graphics user interface. Point and line. It will be covering the first topic, points and line. How it will be identified as a point? It will be identified through the pixels. In CRT monitor, the electronic beam is turned on to illuminate the screen cursor at the selected location. Depending on the display technology, the position of the electronic beam changes. In random scan system, point floating instructions are stored in a display list. The coordinate value is the instructed or covered to deflect voltage, the position electronic beam at the screen location. Next is the low-level procedure for floating point screen at x, y. It is a point for point out the pixels. That set pixel x, y is a function for pointing the pixels. A line is drawn by calculating the intermediate position between the two endpoints. That means 2 points will be connected through the lines that will be drawn through the line functions. Next one is line drawing algorithm. The line drawing algorithm we have already seen about digital differential analyzer, that is a DDA, and another one is a Bresenham's algorithm. The line drawing algorithm A line is a computer graphics is a portion of straight line that extend indefinitely in opposite direction. It is defined by two endpoints because it will be required 2 points that will be connected through the line. It is density should be independent of line length. The slope interception equation for a line y is equal to mx plus b, where m equal to slope of the line, b is equal to intercept of a line. The two endpoints of line segment are specified at the position x1, y1, that is a point 1, and x2, y2, that is a point 2. This will be connected through the line. We can determine the value for slope m and b intercept as m is equal to y2 minus 1 y1 divided by x2 minus x1. That means m is equal to delta y divided by delta x. That means delta y is equal to y2 minus y1 and the delta x equal to x2 minus x1. In the example above the formula we will be discussing through these examples. Next, DDA algorithms, that digital differential analyzer algorithm. It is an incremental scan conversion method. It will be incrementing the point by point and it will be connected through the line. Algorithm x1, y1 is a first point and x2, y2 is the second end point. Then dx, dy are floating variables, where dx equal to absolute ABS value of x2 minus x1 and dy is equal to ABS y2 minus y1. That is first step. If dx is greater than or equal to dy, then length is equal to dx. Otherwise, else length is equal to dy and if. This is a simple if statement for finding the dx and dy. Next one is a dx equal to, how will we are finding the dx equal to x2 minus x1 divided by length. Same as dy is equal to y2 minus y1 divided by length. Then finding the x equal to x1 plus 0.5. It will be useful for the next point. Then another one is a y is equal to y1 plus 0.5. Then I is equal to 0. It is the first point. Float, that it will be useful for the draw and connecting 2 points. Float x, y, that will be connecting. X is equal to x plus dx and y is equal to y plus dy. Then next iteration, I is equal to I plus 1. Automatically it will be increased. Next step, if I less than length, then go to the step 5. Next one is, it will be returning the same step. It will be drawing, again drawing. The iteration will be started. Then after the finishing, it will be reached the last point. Automatically it will be stopped. Same, the example will be given for the drawing algorithm. Next one is limitations of DDA. These two things are major limitation for DDA algorithm. The rounding operation and floating point arithmetic are time-consuming procedure. A round off error can cause the calculated pixel position to drift away from the true line path for long line segment. Next one is Brushenham's line algorithm. This is same like that, but it will be little bit different. It will be incremental scanning conversion algorithm. The biggest advantage of this line algorithm is that it useful only the integer calculation. So automatically it will be more easy. Move the big idea, move across the x-axis in unit interval and at each step choose between two different coordinates. That is every coordinates will be calculated for the line drawing algorithm. Deriving the Brushenham's line drawing algorithm at a sample position xk plus 1, then the vertical separation from the mathematical line are labeled d upper and d lower. In this diagram it will be shown d upper and d lower of the line. It will be finding through the points. The y coordinate on the mathematical line xk plus 1 is equal to, we will be changing x converted as xk plus 1. Already we are know about the x, mx e plus b is equal to y. Same thing it will be increasing the constant values xk plus 1. So y is equal to m of xk plus 1 plus b. The Bresenham's line drawing algorithm, it will be displayed in the algorithm. Bresenham's line drawing algorithm, we are having a few steps. First step is input to line endpoints. It will be for basic requirements, storing the left end point in the x1 and y1. The calculating a constant delta x that is equal to dx, delta y that is equal to dy. 2 delta y and 2 delta x get the first value of the decision parameter is equal to 2 delta y minus delta x. Initialize the starting point, that will be, we are already given a starting value that is an x1 comma y1. Next, initialize I is equal to 1 as a counter, that will be first counter for the next step, is equal to e plus 2 delta y. Otherwise the next point load xk plus 1 comma yk plus 1, then automatically the next point will be connected. Then the final step, it will be repeating step 2, a 4 of delta x minus 1 times, that will be reaching the end of the point. So automatically the line will be drawn through this type of algorithm. Bresenham's examples are shown in the screens. Next, Bresenham's example that will be connecting through these line drawing algorithms. Bresenham's algorithm summaries will be given. The Bresenham's line algorithm has following advantages and fast increment algorithm, because we are using a numerical values, then use only integer calculation, so automatically it will be more fast and efficient. Comparing to this DDA algorithm, DDA has the following problems. What are the problems is that accumulation of round off error can make the pixelized line drafted away from what was intended. Next, the rounding operation and floating point arithmetic involved in are 2 times consuming, so it will be taking a more time, but the Bresenham's algorithm, it will be getting a low times. Loading frame buffer. Next topic is the frame buffer. Frame buffer, a block of memory dedicated to graphic outputs that hold content of what we will be displaying in the screen, so that will be stored through in the frame buffer. It is like a small unit of memory. Pixels. Pixels is one element for the frame buffer. Frame buffer. Each screen pixel corresponding to a particular entry in a 2D array reside in memory. This memory is called a frame buffer or bitmap. Same like that is an image. The number of rows in the frame buffer equal to number of raster lines on the display screen. The number of columns in the equal array equal to the number of pixels in each raster line. The term pixels also used to describe a row and column location in the frame buffer or that corresponding to the screen location. A of 512 into 512 display screen require 262 144 pixels location. It will be like a small example for the mobile screen's resolutions. Frame buffer. Whenever we will be used to display a pixel on the screen, a specific value is placed into the corresponding memory location in the frame buffer array. Each screen pixel location and corresponding memory's location in the frame buffer is accessed by non-negative integer corresponding pair x comma y. X value refers a column, y value refers a row positions. The frame buffer, the origin of the coordinate is the position at the bottom left side of the screen and the upper left side of the screen. Maybe it will be having two places. Frame buffer will be calculated through the binary values. Frame buffer is a memory. If we want to frame buffer into of 640 pixels by 480 pixels, we should allocate a frame buffer 640 into 480 bits. That is equal to every bits having every pixels values. Next one, frame buffer bit depth. How to finding the bit depth of the frame buffer? Bit depth is calculated through the allocation. Number of bits allocated per pixel in the buffer. That is finding for the bit depth. Frame buffer bit depth. how many colors does 1 byte get you? So it will be finding through the frame buffer. Then how many colors to 8 bits to get you? So these type of things through the finding the things through this bit depth. Finding bit depth, it will be more useful for finding through the colors. Bit depth 16 bit per pixel, high color. It will be more high-fied colors like a violet, like the things. 5 bit for red, 5,5/6 bit for green, 5 bit for blue. Potentially of 32 reds, 32 divided by 64 green, 32 for blues. Totally 65536 colors are we are having. 32 bit pixels are true colors. That is a 16 bit is a high color, 32 bit is a true color. It will be having a 8 bit for red, green, blue and alpha. Potentially 256 red, greens and blues. So then total colors is 16777,216, more than 8 can distinguish. Let us look at display control panel. Next one is a line function. We are having a few line functions. One is a set fixer. It will be fix the pixels in the screen. That is, we will be using x, y. That will be coordinates. Color is a color of the pixel. That is a function for set fixer. Then another one is a line. Line will be useful for finding the lines or drawing the line through this type of functions. One is a line x1, y1. That is a first coordinate, x2, y2. That is a second coordinate. It will be connected and drawn the line. Other names is a draw line and line functions we are using. Current position CP. Specify where the system is drawing now. Move to x, y. That will be useful for moving the next position to next position. That will be updated automatically. Line 2, x, y. Draw a straight line from current position x, y and update the current position, and automatically it will be moved to the next position. Next example for one simple square. Move 4, 4. That will be the point will be moving to the 4, 4. Next line to -2, 4. Then automatically the value will be reduced and x-axis value will be coming into the minus x side, minus y side. Then automatically it will be coming and the value, the drawing will be displayed in the screen. Line 2 is a 4, 4. It will be finding the final points. So automatically the square will be coming. Circle. These above things are only for drawing a lines, and through using the lines and pixels what we are doing in the line drawing algorithm. Now we are going to see the topic about circles. Properties of circle. The set of points in the circumference of the circle are at equal distance, or that is from the current center, that is an x, xc, yc, that is a center point of the arc, and it is related given by the Pythagorean theorems. X minus xc whole square plus y minus yc whole square is equal to r squared. Circle generating algorithm. Drawing a circle on the screen is a little complex than drawing a line, because it will be having a lot of points and connecting with the like a arc. So but the line is a single line, automatically the points will be connected, but the finding the point through the line drawing algorithm is more easy, but the circle is not easy, because due to it will be having a point will be connected with a lot of places and it will be changed. There are two popular algorithms we are using for circle generating algorithm. First one is a Bresenham's algorithm and another one is a midpoint circle algorithms. The point in the circumference of the circle can be calculated by unit increments in the x direction from xc minus r to xc plus r. This will be both sides. The corresponding y value is obtained. Y is equal to yc plus r minus root of r squared minus x minus xc squared. Xc, yc is a x center and y center points. To simplify the function evaluation that takes a place on each iteration of our circle drawing algorithm, we can use midpoint circle algorithm. The equation of the circle can be expressed as a function as given below. F of x is equal to x square plus y square minus r square. If the point is inside the circle, then f of x comma y less than 0. If it is outside, then f of x greater than 0. If the point is circumference of the circle, then f of x comma y is equal to 0. Thus the circle function is the decision parameter in the midpoint algorithm. Assume that what we have just plotted xk comma yk, we have a decision desired whether the point xk plus 1 comma yk, otherwise xk plus 1 comma yk minus 1 nearer to the circle, that will be finding the point in the nearer to the circle. We consider the midpoint between the point and define the decision parameter. How will be finding through this type of equation? Pk is equal to f of xk plus 1 comma yk minus 1 by 2. Then xk plus 1 whole square plus yk minus 1 by 2 whole square minus r square. That will be finding these values through this type of functions. Midpoint ellipse drawing algorithm. Midpoint ellipse algorithm is used to draw the ellipse in the computer graphics. Midpoint ellipse algorithm plot the finds point of an ellipse on the first coordinates by dividing coordinate into two regions. Each point x comma y is then projected into the other three coordinates, that is minus x comma y comma x minus y comma minus x comma minus y. That is, it is useful four-way symmetry. Next, function of ellipse. F ellipse of x comma y is equal to r squared y x squared plus rx squared y squared minus rx squared ry squared. F ellipse of x comma y less than 0, then x comma y is inside of the ellipse, that is a point. Then f ellipse x comma y greater than 0 means then x comma y, the point is outside of the ellipse. Then fx comma x comma y is equal to 0, then x comma y, the point is on the ellipse, that means the ellipse line at that point will be located there. Next, midpoint ellipse algorithm that take input radius along x-axis and y-axis and obtain the center of ellipse. Initially we assume ellipse to be center at the origin and first point is x comma y0 is equal to 0 comma ry. Obtain the initial decision parameter for region 1 as p1 of 0 is equal to ry squared plus 1 by 4 rx squared minus rx squared comma ry. For our xk position in region 1 is equal to if p1k less than 0, then the next point along in this point xk plus 1 comma yk and p1k plus 1 equal to p1k plus 2ry squared, then xk plus 1 plus ry squared. The continuation of these equations, that formula, that algorithm, else the next point is xk plus 1 comma yk plus 1, that is a point finding the another one point, that and p1 next point p1k plus 1 is equal to same equation we are already used in the previous thing. In that line we are using p1 then here we are using p1k plus 1, that is p is equal p1k plus 1 is equal to p1k plus 2r squared by then xk plus 1 minus 2rx squared yk plus 1 plus ry squared. Obtain the initial value in the region 2 using the last point x0 comma y0 of the region 1 as per p2 of 0, that is equal to ry squared x0 plus ry 1 by 2 of whole square plus rx squared y of 0 comma minus 1 of whole square minus rx square ry square at each yk in the region 2 starting at k is equal to 0. Perform the following task. If p2k less than 0, then the next point xk comma yk plus 1 and p2k plus 1 is equal to p2k minus rx square yk plus 1 plus rx whole square. Then next is next step is else the next point in the xk plus 1 comma yk minus 1 and p2 of the k plus 1 is equal to p2k plus 2 ry squared xk plus 1 minus 2 rx squared yk plus 1 plus rx squared. Now obtaining the symmetric point in the three coordinates and plot the coordinate value as x is equal to x plus xc and y is equal to y plus yc. Repeat the step for region 1 until these two are y squared into ampersand zt is equal to 2 rx squared y. Next one is line attributes. This is next division of this unit. The line attribute, basically line attribute of the straight line segments are line type, line width, then line color. The line type is solid line, dash line, dotted lines. The solid line means it will be continuous length line. It will be generated setting the length and spacing along the line path. Dash line could be displayed by generating integer dash spacing that in equal. The spaces between the dash is equal for that line. Next one is a dotted line. This can be displayed and generate very short dash with the spacing equal to or greater than the dash size. Next, to set the line type attribute through this function, set line type LT. That value is we are having three types of lines already. We are know about solid line, dash line, dotted lines. That the parameters, one is displayed as a solid line, two is dash line, third one, three is a dotted lines or dash dotted lines. Already we are displaying in the screen that solid line, then dash line, then dotted line. Then line width will be calculated through the pixel size. Then butt cap, rounded cap, projecting square cap, meter cap, round join, then bevel join. Next, line color. A polygon procedure display a line in current color by setting this color value is frame buffer at pixel location along the line path using the set pixel function. Set polyline color index function is used to set the color of the lines. Then pen and brush option. Line can be displayed with pen or brush selection. The pen or brush option include shapes, size and pattern. That shapes will be what size the shape will be available for designing the pen. Then size is different type of drawing items. Then pattern, what pattern we are drawing the items. Pen and brush can be stored in the pixel mask that identify the array of pixel position that are set along the line path. Next, sample designs for the paint brushing. Next, curve attribute. Similar to a line, type plus width. That means we are setting the curve attribute and plus width. The size will be different. Thicker curve can be produced by plotting. Second one is filling the space additional pixels between two concentric circles. Then using thicker pen or brush. It is different. Curve attribute will be displayed in the screen that will be finding under pixels continuously. Next, width. Then color and grayscale level. Color are represented by color code which are positive integers. Color information is stored in the frame buffer or in the separate table and use pixel values as an index in the color table. Two ways to storing the color information. That one is a direct and another one is an indirect. Color pickup screen, already we are know how to pick up the color through the color pickup the window. It will be displayed in the already we are used in the Photoshop Coral Draw, everything we are using. Same thing we are using in the color pickup screen. Next, two way to storing the coloring information frame buffer. We can store color code directly in the frame buffer. Then automatically the color frame buffers will be displaying, giving color to the diagrams. We can put the color codes in the separate table and use pixel values through the using the index in the table. Color code table will be displayed. Color code is 02 till 0 to 7. Then RGB, already we know that RGB is a red, green, blue. That will be through the binary values, change the binary values. The colors is displayed 0, 0, 0 for both RGB means automatically the color is black. Suppose the color 0 for R and 0 for green means, then 1 for the blue means automatically the color entirely blue. Same like that. For example, red is 1, then green, then blue is both are 0 means automatically the color red will be coming. For example, the triple 1, that means R is 1, Z is 1, then B is 1 means automatically the color is white. Advantage of using color lookup table. Without requiring a large frame buffer, we can provide a reasonable number of colors. Allow a user to experiment with different color combination in design, scene and graph. Without changing a pixel value, we can store visualization application values. These are all are advantages of using color lookup table. Grayscale. Grayscale is a range for monochromatic shades from black to white. Therefore, a grayscale image contains only shade of the gray and no color. It will not be displaying any color, but it will be giving a shadow of that image. While displaying an image can be saved in a grayscale image, even color image containing a grayscale information. Grayscale level is 16 level, 32 levels, then 256 levels. Automatically that will be partitioned as a multiple divisions. That is a high level grayscale concepts. Then area filling attributes. Area fill paint as a defined area with a specific color or pattern. We are fill the specific area that will be through our color or pattern. If a area is defined by set of boundary pixel, there are specific algorithm for area filling starting from seed pixel inside the boundaries. Filling styles. There are 4 basic filling styles we are following. One is a hollow, that is a blank, that will be covering the blank colors. That will not be displaying any colors, that means white, only it will be displaying a white. Next one is a solid color. Solid color, it will be displaying a solid color, red, blue, green, we are selecting the colors. Next one is a pattern. We are already know what are the patterns we are having. That will be displaying like a designs. Then hatch is a diagonal or diagonal cross. That means it will be displaying as a diagonal or diagonal cross, opposite of the diagonal. Next one is a sample example for the filling, hollow and solid. Next hatch concept. Next pattern designs like that. Next texture type is we are now advanced concept. We are using a texture type of filling. This will be displaying a specific area color, filling the colors, and it will be like an image type of concept. Functions for filling areas. We are following few functions for filling that specific areas. That specific area means we are selecting that specific location. Set fill style function. This will be filling the patterns type, what style we are using. Floor fill function is used to fill an enclosed area. Set interior style index. That will be different type of pattern we are using. That pattern ID will be given. Then the pattern ID will be automatically picked up and matched with the pattern parameters. Then automatically the pattern will be displayed in our pictures. Next, fill area, that n comma points. Which points we have to fill the points values. Next, other functions used for setting other style follows. One is a set pattern size. What type of size have to display in that specific area? That means in a single box or 2 box or 3 box or 4 box, it will be giving a different type of size. Next, set pattern reference point. It will be the position of that point. Next, soft fill, modified boundary fill and floor fill procedures that are applied to repainting areas. So that fill the color is combined with the background color and refer the soft and or thin fill. Uses for this fill area. It used for recolor or repaint. Recolor means we are changing the color, or repaint it will be same but little bit difference. So that we can obtain a layer multiple color and get new color combinations. That will be background color and our forecolor will be mixed. Then the new color will be combination will be occurred. Allow the next point, to allow repainting of a color area that was originally filled with semi-transparent brush, where the current color is the mixture of brush color, the background color behind the area. Next one is a character attribute. This is a final concept in that unit. Text and character. We all already know about the text and characters. Very important output primitive. It will be presenting the content of that whatever information we have to display it as a graphics. Many pictures require a text for displaying a names or description of the images or videos, everything. Two general techniques used. One is a bitmapped raster and stroked outline. Each character represented as a 2D. 2D is a two-dimensional array. That means a row and column wise. Each element corresponding a fixed rectangle cells. Then the values will be fixed in that rectangle cells. Then automatically the image will be appeared as a fixed concept. Simplest, each element in a bit, one pixel per one pixel unit. Then sample attributes, text color, text fill, text pattern and the text size. Thank you.